These are notes for AP Calculus AB. This is our Unit 9, which is our last unit, and 9.1 is going to start us off with the derivative of inverse trig functions. So there's just a couple more formulas in this unit that we have to know on top of our previous unit where we learned 10 new formulas. So the first thing I'm doing here is reviewing inverse trig functions and going through the range of values for all 6 of them. So you can see the chart here tells us and reminds us about inverse, sine, cosecant, and tangent existing from negative pi over 2 to pi over 2. Inverse cosine, secant, and cotangent existing from 0 to pi. For each trig function, there's a quadrant 1 where they're all positive, and then there's a quadrant where they're all negative. They're always next to one another, so you'll notice that quadrant 3 is never used. You want to remember these so that when we get to evaluating them, you'll know how to plug in the numbers. So that's why we're going to start with a little bit of review of evaluating inverse trig. So we'll start number 1 with inverse cosecant of 2 over root 3. So we're looking for where cosecant gives us the ratio of 2 over root 3. So first of all, inverse cosecant is a positive number in quadrant 1. So it'll be helpful to draw it out. Quadrant 1, we need a ray here. We'll drop the side to the x-axis to create the right triangle. Cosecant's the reciprocal of sine, so our labeling is hypotenuse over the opposite side. So this is 2 over root 3. That makes this side 1. That makes this 60 degrees, or pi over 3. Okay, and so we evaluate all of them this way. So number 2, inverse cosine of negative root 3 over 2. So now inverse cosine of a negative number is in quadrant 2. So we draw our ray in quadrant 2. And we label the sides adjacent negative root 3, hypotenuse 2. That makes the missing side a 1. This is 30 degrees, or pi over 6 for the reference angle. But we don't want to answer with 30 degrees or pi over 6 since that is an angle in quadrant 1, and we're looking for an angle in quadrant 2. So 30 degrees, or the pi over 6 angle in quadrant 2 is 5 pi over 6. All right, inverse tangent of negative root 3 over 3. So inverse tangent is negative in quadrant 4. So here we go in quadrant 4. We want to label, except we don't have such sides as opposite negative root 3, adjacent positive 3. You need to realize that this value has been rationalized and was negative 1 over root 3. So we actually have opposite negative 1 over adjacent root 3. So hypotenuse 2, that does make this a 30 degrees or pi over 6 reference angle. But you have to remember, in order to get into quadrant 4, you have to follow the negative directional arrow. So in the negative direction, this is negative 30 degrees or negative pi over 6. All right. So that's just a little bit of review. And now I want to move on and give you those derivative formulas. All right, so the derivative of arc sine u, so derivative of u with respect to x. So these will all have the chain rule piece like we did with all of our formulas. There's always that du dx at the end. So the derivative of inverse sine is 1 over the square root of 1 minus u squared. And followed by your chain rule du dx. So that's it. You do want to make sure you know where the stuff inside inverse sine goes here, and then we want to multiply by the derivative of that piece. So the chain rule following there. The next one is the derivative of arc tangent, which is 1 over 1 plus u squared. So a little bit different. There's a plus and there's no square root, but they are very similar formulas, followed by du dx. So again, just knowing that u value and then multiplying by that derivative. The third one is the derivative of arc secant. This is 1 over the absolute value of u times the root of u squared minus 1 du dx. Kind of the ugliest of them all. It's just got the most stuff going on. So again, you take your u term. It actually goes in 2 spots here, times du dx. So it looks similar to arc sine. It has that square root, but you'll notice the values are backwards. We have 1 minus u squared and u squared minus 1. And with subtraction, that order matters. So we want to make sure that we have it in the right spot. I just remember that with arc secant, because it has that extra u on the outside, I always want the u's right next to one another. And that reminds me that arc sine goes 1 minus u squared as opposed to u squared minus 1. Now, these are really the only 3 you have to know, because the other 3 that correspond are the same except negative. So if you're given the derivative of arc cosine u, it's the same, except you have to multiply it by a negative 1. So you'll have negative 1 over 1 over root 1 minus u squared du dx. And so it's the same this way for all of them. So just like we learned back in Unit 2 with the derivative of cosine, cotangent, and cosecant, any of the ones that start with a C have a negative derivative. It's the same if they're inverse trig functions. So same formula, except now it's got a negative 1 in the numerator instead of a positive 1. Okay, so those are the formulas, and with that, we're going to work on some examples. All right, so in this one you see the arc cosine to begin with, and like I mentioned earlier, if it does start with that C, so arc cosine or any of these, we want to lead off with a negative 1 in the numerator. So we're going to start with negative 1 divided by, and then we'll build in our square root of 1 minus u squared. So this is my u term. So in this problem, the u term is 2x. And then we want to multiply by the derivative of 2x, which is 2. So that's pretty much it. We just want to simplify this. So now I have negative 2 in my numerator over the root of 1 minus 4x squared. That's going to be our answer. All right, so this one is the derivative for arc secant. So we are looking at this formula here. My u term is the root of x, so we'll start with 1 over the absolute value of u. So absolute value of root x, which is unnecessary, as the square root is already making sure that we have a positive value here. So we're not going to need to keep those absolute value symbols, but I'm going to write them down for now and then simplify. And then we have times the square root of u squared minus 1. So the u term squared minus 1. So u is root x, so root x squared. And then times the derivative of root x, which is 1 over 2 root x. Right? Derivative of root x, 1 over 2 root x. So then we just want to simplify. So we have 1 over. So this is going to be 2 times x. Root x times root x is just going to give us x. And inside we have x minus 1. And so there's our final simplified answer. All right, this one is arc cosecant of e to the power 2x. So this time, sorry, it should be e to the power 2x. So that's going to be our u term there. Okay. So again, it starts with a c, so we do want to lead off with that negative 1. It's going to be the same secant formula, just with a negative 1 in the numerator. So we'll start with on the outside the absolute value of our u term, which is e to the 2x. Again, e is exponential growth and is always positive, so we're not going to need to keep those absolute value symbols. Inside we have u squared minus 1. So u is e to the 2x. And then we last want to multiply with the derivative of e to the 2x. So that's just e to the 2x times 2, because we want to take the derivative of the exponent as well. Okay? So this would be negative 2 e to the 2x. In the denominator, I don't need the absolute value symbols, so you have e to the 2x here as well, times the square root of, we forgot to square this, e to the 2x squared. So multiply your exponents, e to the 4x minus 1. Now the e to the 2x's on the outside can reduce, and we're left with negative 2 over the root of e to the 4x minus 1. And so in the end, it might not look like the inverse secant formula anymore because it no longer has that u term on the outside. I can tell that it is, though, because it leads off with the u term minus 1. All right, so we have one more example that I want to show you here. Let's see, arc cosine of x over 2. So this is a little different because it's created this fraction inside. Okay, x over 2 or 1/2 x. So finding the derivative here. So again, when I take the derivative of inverse cosine, it's just going to be the same as inverse sine, but starting off with that negative 1 in the numerator. Okay, and underneath we have the square root of 1 minus our u term squared times du dx. So this would be x over 2, and then the derivative of 1/2 x is just 1/2. So it looks harmless enough, and that is your derivative there, 1 over, we're going to write 2 root 1 minus x squared over 4. Now, you can't leave the answer this way because you've got a little fraction inside of the larger fraction, and so we have to simplify this. So the first thing I want to do, and so this is all just algebra work here that you're doing that's tricky. We want to get a common denominator, okay, of 4. So this will become negative 1 over 2 root 4 minus x squared over 4. So there's the common denominator inside. Now the nice thing is you've basically created one term, and if it helps, you might write it this way. You have a 1/4 of 4 minus x squared. That's what this is. Okay, so I just pulled that 1/4 in front of the 4 minus x squared. So because of the multiplication, I can actually square root the 1/4. So if I square root 1/4, the square root of 1/4 is 1/2, and you're just left with the root of 4 minus x squared. You can now reduce this to 1, and you have -1 over the root of 4 minus x squared. And that is your final answer there. So you might see one or two of these on the homework assignment. If you can get to the derivative, good. The rest is just some algebra here. And you do want to know these 3 formulas in Objective 2. We'll be doing what's a little bit harder is integrating back to the inverse trig function. So make sure you do practice this.